students, welcome to next class 10th. Okay, so today we will learn the next concept. So in the previous video we have learned regarding the spinels. Okay, so different types of spinels. Today we'll go for the garnets. So today we'll learn regarding the garnets. These garnets, if you see the crystal system, so they are in cubic system. Okay, cubic, or it is called isometric, okay, system, I can say crystal system. This is important, crystal system. And they have neosilicate structure. Okay, neosilicate structure, a nesosilicate is called as nesosilicate. Okay, silicate structure. So nesosilicate means what? SiO4 la, SiO4 4 minus, like this. Okay, so tetrahedral structure will be there. So this we will see. Okay, so this we will learn, nesosilicate, and it is having the general formula. So if you have the general formula, so it is having the general formula of X3Y2 Si3O12. This is common silicate. That's what I said. Nesosilicate type of this one. So this silica and oxide, this is a common factor in this garnets. Okay, X3Y2. Okay, X3Y2. So this is the general formula where this X3Y2, X stands for the divalent. Okay, so divalent ions. Okay, like you can take calcium Ca+2, magnesium +2, iron +2, manganese +2, like this. Okay, and this is about X. And Y is nothing but trivalent. Okay, so this is your trivalent, like Al+3, Fe+3, ferric. Okay, and chromium +3, titanium plus, like this. So this is how the X and Y termed as, and Si, X and Y and Si, this is a common will be there. And among this, if you see the principal minerals okay, of the garnets, if you see, so there are some very important garnets here. So that's grossular. Okay, so you remember this pyrope, pyrope. Then it is almandine. Okay, then spessartine, spessartine. Okay, spessartine. Then andradite. Okay, and uraorite. Okay, so you can see here grossular, then pyrope, then third is almandine, fourth spessartine, five andradite, and uraorite. So these are the main principal minerals of the garnets. Okay, and grossular, so they are having some chemical composition, that is your calcium Ca3Al2. So okay, you can remember this. And I said this is a common, what is that? Ca3. So you see the general formula, Ca3Al2, Si3O4. Okay, Si3O4. So this is a common. Okay, this is about calcium, grossular. Then pyrope, there is a magnesium. Okay, Mg3Al2, magnesium mineral. Then almandine, Fe3, this is of Fe3Al2. Okay, so this is that. Then spessartine is again here, manganese, Mn3 Al2. Okay, this is spessartine. Then andradite, it is calcium iron, Ca3 Fe2. And finally you can see uraorite, it is again calcium Cr2. Okay, and this remains the same here, Si3O4, 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 silica. Okay, like this. So these are the main principal minerals of the of, you can say, garnets. Okay, so you can remember here GPaSAu. Okay, GPaSAu. So grossular is a calcium aluminum rich mineral garnets. Then you can see here aluminium for the first four is same here. Okay, so you can see here Al2 for grossular, pyrope, almandine, spessartine. Okay, And Glassular is calcium mineral, pyrope is magnesium rich, almandine is iron, and spessartine is manganese. Okay, last one too, you can say andradite and uraurite is different here. That's no aluminum here, so it is Fe2Cr2 chromium, this last one. Okay, and both are calcium here, both are of calcium, but the this is changing here. In all the cases, 4 cases it was aluminum, but final two, that is andradite and urobite, it is iron and chromium. So this is how you have to see the chemical formula and try to understand and make a simple way to remember this also. So this is very much important. Okay, now if you see the Glassular here, so this Glassular, the first what we are seeing, Glassular, so it's a Latin name. Okay, so it is having it is called a Latin name, okay, for this mineral, which is got from Grassularia, obtained from Glassularia, that is called pale green gooseberry, pale green gooseberry. Okay, so it is obtained from this Grassular. Okay, so it is a Latin name here. And similarly, next one is pyrope. Pyre means what? Fire, you know, that's a Greek word, so it has come from the Greek word. Pyrope means fire, that is a fiery, F-I-E-R-Y, fiery, fire. Okay, and this is what. And almandine has come from Alabanda. Okay, so from Alabanda name, the almandine, that is third one, almandine has come this has the name has come here. Then andradite is andradite. Okay, this andradite is a Portuguese microbiologist, it's a name on the scientist. Okay, andradite, so this name has come from the scientist name. So he was a Portuguese mineralogist, Portuguese mineralogist. Okay, so during 1763 to 1838, during this, okay, 1760 to 1838, andradite was been found by the Portuguese mineralogist. Okay, so this is what you have to keep in the mind. And last is uravorite. Okay, so this is also found by the president of St. Petersburg, Russia. This was found by president of St. Petersburg, okay, Russia. So okay, this was been found here. This also during 1785 to 1855, this range. Okay, St. Petersburg, Russia. So there it was Eurovaric was been introduced. Okay, this is how the, you can say, the minerals used to, the name used to be name has been proposed. Now if you see the types here, so classification, if you see, they are classified into two series. This is important here. So two series, so name of depending on their function properties, I can say two series. So that is on pyral spite series. And in another this you can see, it has been classified Ugrandite series. Okay, so pyral spite series and ugrandite series. So this is how in two series these granites has been classified. So in pyral spite here, in pyral spite series, you see there is a pyrope, almandine, okay, then spessartine, like this. Okay, so that's why it's called spiral spite. Pi means what? Pyrope, al means almandine, spite means spessartine. So these three comes in this series, two series. Okay, spiral spite series. That's py means pyrope, al means almandine, spite means spessartine. So like this. Similarly here, ugrandite series. In ugrandite series, you can see grossular, then andradite, and last one is uravorite, like this. Okay, so this is how you can see they are being classified in two types, that is pyral spite and ugrandite. So pyral spite, you can see these three is coming under this because of that nature. Ugrandite series, you can see they are coming this grassular, andradite, and uravorite will come in this. That's why uravorite, so ugrandite. So this is how the name of the minerals here of granites have been come here. in which they are divided into two series, whatever we have learned here. So depending of 7 here, so they have been they are divided into two series. So this is what one thing you have to keep in the mind of these garnets here. Okay, now usually if you see the physical property of this garnets, so what is the main here, that they are like gemstones. Okay, garnets are gemstones. Okay, and they have some forms, okay, or structures like dodecahedron or trapezohedron, okay, or it is having a granular structure or equant or equigranular. So these are some of the forms of the garnets. Okay, dodecahedron or trapezohedron, like that. And color, if you see, color is pale olive green or greenish white color. Okay, or sometimes yellow purple color. So yellow purple color for Glassular, you can see Glassular. So they have this color, yellow purple color. Okay, then deep crimson color will be there, deep crimson. Okay, deep crimson color like pyrope. So this pyrope mineral has a deep crimson color, deep red color almandine, like this. Okay, so they have deep red color or dark brown color, like this. So they have such type of colors. Okay, light colors will be there and very beautiful shining. This will be there for this garnet. That's why they are used as gemstones. Okay, now if you see this cleavage is absent here, that is very much important. There is no cleavage is absent in this. Okay, so then if you see luster, it is vitreous. Luster of this garnets is vitreous luster. Okay, then hardness, definitely hardness equivalent to that of the diamond, that is 6 to 7.5 hardness will be there. Okay, so this we have to specific gravity also is very high. Specific gravity around 3.5 to 4.5. This is a specific gravity of this garnets. Then white streak will be of white. Okay, white streak. They are having cuttings. Fractures, if you see, it is conchoidal. These are physics mineral related words here. Conchoidal or too uneven. Okay, this is the fractures. Okay, that is the cuttings, conchoidal to uneven. So this is the fractures, like this. Okay, so these are some of the, you can see some of the physical properties of the garnets. Okay, and if anybody asks most common form of garnets, if that is the most common form of garnets. Okay, so you can tell any of this, that is trapezohedron garnets, or rhombic dodecahedron. Okay, or simple dodecahedron, like this. So these are the most common form of the garnets. Okay, what is dodecahedron? You know, dodeca means what? Having 12 faces. Okay, so which is having 12 faces of somewhat having a pentagonal like structure, like this. Okay, so 1 2 3 4 5 6 and backside 1 2 3 4 5, like this. So it's very beautiful structure is there. So you can see the garnet structure on my cover this one, whatever I'm sending you, the face on the face of this video, you can see that garnet structure. Okay, so dodecahedron, so they have some pentagonal like structure, like this. 12 faces will be there, and you having the general symbol of 110. Okay, this is what 110, they have the general symbol of 110. Similarly trapezo, okay, having 24 faces, very simple. Okay, so like here I have seen, so three common, that is trapezohedron, dodecahedron, 12 faces, but trapezohedron is 24 faces. Okay, and they have the general symbol of this trapezohedron is HLL. Okay, or 211, this one. So sometimes it will be helpful for you in net examination. So trapezo has 24 faces with the general formula symbol HLL or 211, and this having 12 faces. Okay, dodecahedron with the general symbol 110. Okay, so this is what. Then you have seen granular. So equant means what? Equant granular, you know that equant is cubic crystal, actually similar. Okay, equant is cubic crystal. Equant means equal. Okay, they have the similar same shape, all axis in the all axis of sample, so they call equant. Equant or this what we say when this is we are given what is that equivalent or equigranular, equigranular like this. Okay, so this is what the sum of the physical properties as well as the form of the you can say of the garnets. Okay, now we'll go for the next concept of the garnets here. So usually the color, if you see the garnets, the iron which is present is responsible. So whatever the iron which is present in the garnets, it is responsible for red yellowish green, red yellowish green color. Okay, so this is, and the commonly occurring yellow and brown colors. So this is what commonly, what I said, commonly occurring red and yellow and brown color. So iron content in the garnets, they are responsible. Okay, and even the color for emerald. Okay, so these all things we keep in this all no, we rings and all, finger rings and all, we use this, no, different stones and all. So that's what emerald also we use in the gold chain, golden ring, finger ring and all. Okay, so this emerald also has green, we call as green garnets, green color will be there, and it is due to chromium. Okay, so it is present, chromium is present, and these have refractive index very high usually. Okay, so refractive index to the level of 1.75 to 1.8. This is what the refractive index is. Okay, so it is high usually, and from Glassular to Uravorite it decreases. Okay, that is what, so Ri decreases. So from 1 to 7 what we have learned now, so from 1 to 7. Okay, GPA, SAU, so that is what. So here if you see the Ri value, it decreases like this. Okay, so if it starts from 1.67, so last one is 1.83 like this. Okay, so this is the highest Ri value. Okay, refractive index value is highest for Uravorite and lowest for this, but the two very lowest will be of one mineral, that is hydrogrossular. This is the lowest Ri, so this is having very less Ri here. So nearly 1.6 like this. Okay, above this will be this one, so 1.67 like this. So hydrogrossular is one mineral of the garnets which is having the very less. They also, this may also be asked in the examination. 1.6, this is having very less the what you say refractive index value. Okay, so this is what about one thing to blend. And optical property, if you see of this optical properties, okay, of these garnets. Okay, so this all garnets are usually usually they are also found in colorless to pale pinkish. Okay, it's not so much this one, but they are very little color will be there, and sometimes colorless to pale pinkish will be there, and dark also. Okay, in some of the isotropic dark color isotropic. So this also you can see in this one, and you can see some of the quartz mica. Okay, so this also you have seen with high refractive index value 1.8 like this. Okay, and they are formed in different varieties. These garnets are got in different varieties. Okay, like you can see cinnamon stone. Okay, so like this they are getting in different varieties. Okay, so which is a calcium aluminum rich cinnamon stone, calcium aluminum rich mineral cinnamon stone, colophomine, colophonite like this. Okay, they are formed in, then pyrenite, Reneit, pyrenite. Okay, pyrenite like this. Then melamite, which is a black granite. Okay, melamite, which is got in igneous rock like this. Okay, so like this you can see. Then one more is there, topazolite. Okay, topazolite. Then dementoid like this. Okay, so like this we can see that there are different varieties. Okay, different varieties of these garnets, like this in a cinnamon stone, then colophonite, pyrenite, then melamite, which is a black garnet, topazolite, dementoid, like this. Okay, so definitely they are got in different varieties with different names. This also you have to keep in the mind. Okay, and these garnets may be altered, so whether this is difficult to alter it, but definitely garnets can be altered also. Okay, so they can be changed sometimes. Okay, very difficult, very stable, but sometimes they can be altered to chloride. Okay, they can be altered to chloride, and or occasionally some other minerals such as hornblende. Even some other minerals they can be altered to hornblende, HORNBLE, hornblende, epidote. These are all new words, epidote, or iron oxides, like this. Okay, so they can be altered. So okay, this is very important. Granites can be altered, very difficult, but yes, it can be altered to chloride, sometimes hornblende or epidote or iron oxides. Okay, so this also helps you in answering some of your competitive questions. Okay, now the distinguishing features, if you see, distinguishing features distinguishing features. Okay, how we can identify this garnets, this one, how we can come to know? Only thing is what, the high refractive index, that is clear. So it is having high refractive index. Okay, in the technical word it is called as the mineralogist word, it can call be a relief, RELIEF, like this. So RI, this we call as a relief, this word we use. And isotropic in nature, tropic. Okay, so this is what. And generally these minerals are less strongly colored. Okay, they are less strongly colored. This also is important. Okay, these minerals are less strongly colored compared to spinels. Okay, if you see the spinels, these are less strongly colored. This is how you can distinguish. Okay, and as I said, hydroglossular, lowest is the hydroglossular. This is the lowest Ri having. And what is this? I said this is calcium aluminum rich, Ca3Al2Si2O8. Okay, Si2O8, and even hydroxide is the water, this will be there. So X times, like this. So this is what about the hydroglossular composition here. Okay, so this is having the low refractive index. Okay, now this is the only natural anhydrous garnets. Okay, so this is what. Then which can be separate from normal garnets. Okay, normal garnets, so this is a different form. So this is the one of the hydrated garnets here. Okay, and they are formed usually where these garnets are formed, they are found. Okay, they are found garnets in the metamorphic rocks. Okay, so this is what and rocks in between the earth, below the earth and all. So there is a high temperature here, the heat and pressure of metamorphism, that is important. Pressure Heat and pressure. Okay, which was created in the metamorphism, they break the chemical bond. Usually they break the chemical bond here and causes such minerals. Okay, this is what the nature's gift, I can say. Okay, which is got in metamorphic rocks, and the heat and pressure will be more in these rocks, and that break the chemical bond of these constituents, and that creates the minerals. Okay, and minerals to crystallize minerals to crystallized into a stable structure. Okay, so under the that particular working temperature and pressure. So this is how the garnets come into the nature here, and that is how the human being extract these garnets from such this one. Okay, from the rocks. So you can see that the aluminum almandine. So these are all examples. Pyrope, if you see, it is more stable in high pressure rocks. Pyrope also, this mineral pyrope. Okay, garnets, they are more stable. Usually they are very more stable in high pressure. Okay, high pressure rocks deep in the earth. High pressure rocks. Okay, which are present deep in earth, under the earth sometimes, like this. Okay, this will be there, metallurgical effect will be there. So this all comes here. So this is how the pyrope is obtained. Pyrope is got here. And spessartine also is manganese rich. spessartine. Okay, so this also is a manganese rich manganese rich found in low grade metamorphic rocks. They are found in low grade metamorphic rocks. Okay, low grade metamorphic rocks like this. Okay, and the common minerals, igneous rocks. This also we have to remember. Igneous rocks we call igneous, igneous rocks. Okay, like quartz, feldspar. Okay, these all are garnets, mica, like this. Okay, so this is obtained in this form, spessartine. Okay, minerals like this, in this form they are going to obtain here. And grossular is found in marbles. Grossular, they are found in marbles. Okay, wherever you see no marbles and all. So this is a form of grossular which is mainly found in calcite, grossular, dolomite. In dolomite mineral you can see, then quartz again. Okay, olastonite, it is called as olastonite. Okay, where grossular is a form of glassular, diopside like this. Okay, so these are some of the grossular mode of minerals. Okay, which are mainly found in the minerals, in the marbles. And these are some of the forms. Okay, like this. And last, urovite, you know that uraorite white. Okay, this is a chrome ore, CHROM, because they are having chromium, no, so chrome ore like this. They are from the, these are rare minerals. Okay, very rare mineral found in peridolites. Okay, so very rare mineral, uraorites, but they are found as a chrome ore in peridolites. Okay, so this also you have to remember. Then then one more classifying as their kimberlitic garnets. Okay, so what is this norringite? So we call it as a KNORR, norringite, GIT. Okay, norringite. So having the composition of magnesium chromium 2, Si3O12. This is the composition. Okay, magnesium 3, norringate garnets. Okay, kimberlitic garnets. So Mg3 Cr2 Si3O12. This is the composition of this. Okay, so even gold manite. Okay, so this is one more garnet here mineral, so which is having vanadium as one of the dopings here, very minute rare elements here. Vanadium 2, which is in +3 state here, Si3O12 like this. Okay, this is goldmanite. So I'm taking here because it will help you in some of the computer examinations. This you have to somewhat you keep in the mind. Okay, so not necessary. So goldamite is nothing but vanadium like this. Vanadium is there inside this. Okay, and usually whatever the reaction takes place here is CaCO3, that is your limestone in the metamorphic rocks. Okay, when it is been reacted with atmospheric pressure, temperature, with Fe2O3 which is present, and under this silica, okay, whatever is present, so it is going to form your this one Ca3Fe2 Si3O12, and with remaining carbon dioxide, giving out the carbon dioxide. Okay, this is your what? Garnet. Okay, that is which garnet? Andradite like this. Okay, this is how the reaction takes place usually, and you are going to get these garnets like this with liberation of carbon dioxide. Okay, andradite is got here. So this is how the igneous rock. Okay, we get this. This is what limestone. So this all like this it happens, and the garnets is gone. And as I said, nesosilicate structure. Nesosilicate, I think in second semester you have learned this. Silica with having this oxygen in all tetrahedral like this. Okay, like this, something like that. 4 oxygen will be there, and you can join it here like this, or like this. Okay, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, like this. Okay, all 4 minus charge will be there. In between you can see silica is there here. In between silica is there. Okay, so this type of structure we can see SiO4 4 minus. Okay, so this type of structure you can see, that is called nesosilicate. So such type of tetrahedral structure. Okay, alternated by octahedral like this, tetrahedral. So such type of structure is such type of this usually is made up of garnets are made. Okay, and that structure you can see in the my whatever I'm sending you, that okay, gems and all you have seen it. So I can't put it here, but from the slide you can see the first slide what I'm going to put on the cover page of this video. So there you can see that how the garnets will be. Okay, hope this is more than sufficient point to be remembered examination point of view regarding the garnets. Okay, so very very important here, and that's why because of such difficulty, so these stones are very costly also. Okay, so very costly and have some power also. Okay, so that thing is very important because this is a natural process. Okay, not a man-made. So extraction is there, everything. So very beautiful. So you have to remember this classification types and some of the points of these physical or optical properties more than sufficient. Okay, thank you.